The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. Lesson 39, Earth Geometry, Latitude and Longitude. In this lesson, we will locate points on the Earth's surface, given its lines of latitude and longitude, and find the radius and circumference of a circle of latitude. The Earth is approximately spherical in shape, with a radius of about 6,370 kilometers. Any point on the Earth's surface can be fixed by using two angles. However, the two reference planes must be fixed at right angles to each other. If you look at a picture of the Earth as seen on the right, you would recognize the equator. The equator would represent one plane, and the plane connecting north to south, north at the top, south at the bottom, that plane is another plane that will divide the Earth into four equal parts. So you have the north-south plane and the equator. Notice there's a mark there for the circle passing through north-south. That circle is our 0 degrees, our reference point, and that circle is called Greenwich meridian. Can you identify the two reference planes? Well, I mentioned them a moment ago, but you need to probably draw and see if you can have a solid model to cut to illustrate the two planes referred to here. The line of latitude, whose center is also the center of the Earth and forms a great circle, is called the equator. Now notice the equator is a circle. The center of the equator is the center of the Earth, and it is labeled 0 degrees latitude. If the Earth is sliced continuously perpendicular to the north-south axis, the circles formed on its surface are called lines of latitude. Latitude ranges from 0 degrees to 90 degrees north, or 0 degrees to 90 degrees south of the equator. A great circle is any circle on the Earth's surface whose center is the center of the Earth. We look at circles going the other way now, going through North Pole and South Pole. All great circles passing through the points north, that's the North Pole, and the South Pole, are called meridians. The meridian, or line of longitude, that is designated 0 degree longitude, is accepted as Greenwich meridian. Longitude of a point is measured 0 degrees to 180 degrees east of the meridian of Greenwich, or 0 degrees to 180 degrees west of the Greenwich meridian. you can look at the picture on your right, and you see there are several lines of longitude, each passing through the North Pole and the South Pole. And you must remember that the equator is also a great circle, but although it is a great circle, it is not a line of longitude, but it is the line of latitude, which is the equator. And the equator is the circle that has the greatest circumference latitude-wise. Compare and contrast latitude and longitude as presented in these two pictures. The Earth represented on the left, which show the latitudes running east to west or west to east. And the latitudes are all parallel to the equator. So you would recognize the equator, and the angular measurement there is 0 degree. And as you go up, you will go in degrees north. So you recognize 30 degrees there. The latitude that is at 30 degrees there at the top is 30 degrees north latitude. And you keep going up like that until you reach 90 degrees north latitude. So you're moving from 0 to 90. If you take the south, you will have measures of latitude south of the equator, and you'd have seen the latitude line 30 degrees, which will be 30 degrees south of the equator. And if we keep going down towards the South Pole, we'll find as we reach the South Pole is 90 degrees south latitude. On the right, we have the longitude. And notice the longitude are circles running through the poles, that is the North Pole as well as the South Pole. And you see a dark vertical line showing there. At the bottom, you see 0 degree, and at the top 180 degree. That line is called the prime meridian line, and it is used to measure time. And if we go east of the line, and notice where east is to your right. So if you go 30 degrees east, it will be a circle making 30 degrees with the plane of the prime meridian. If we go west, we go so many degrees west longitude. If we go east, we go so many degrees east longitude. Some important points to note. A circle on the surface of the Earth whose center is at the center of the Earth is called a great circle. All points on the same circle of latitude have the same latitude. All points on the same meridian have the same longitude. Here's an example taken from CXC June 2005. The latitudes and longitudes of Antigua and of Belize are given in the table below. In the first column, we have the country. In the second column, we have the latitude. And in the third column, the longitude. So Antigua is 17 degrees north latitude and 62 degrees west longitude. Belize is 17 degrees north latitude and 88 degrees west longitude. And notice that Antigua and Belize both share the same line of latitude. You're asked to draw a sketch of the Earth showing the location of Antigua and of Belize, their associated circles of latitude and longitude, the equator, and the Greenwich meridian. Here is the solution. We have a picture of the Earth. We draw our equator that's going through the middle across the globe, and name that 0 degree. Above it, we draw another circle, label it 17 degrees north. Then we look for the great circle, and we have to go west of the Greenwich meridian, which is marked here. If we go west, we go for point A, Antigua, which is 62 degrees west, and mark that intersection point A for Antigua. Then we continue going west until we reach 88 degrees. That intersection point is labeled B for Belize. So we can see from the picture the relative positions of A and B. Notice where north is. North is at the top of the globe. How to find the radius of a circle of latitude? Here we have a picture of the globe again. It's a glass globe that you can see through, so it's a model. We have the north position mark, the south position mark. The Greenwich meridian is marked there, and you have the equator. You have the center of the Earth marked O. We have a line showing the radius, and you notice there is a circle at the top and a radius to the circle, and you see the angle theta marked there, and the line RT is parallel to the radius of the Earth, and so you have alternate angles, and theta is equal to theta as marked there. So let us consider triangle ROT. Notice where R is, where T is, where O. O is the center. Angle OTR is equal to theta, and OT is equal to big R referring to the radius of the Earth, and small r referring to the radius of a line of latitude. So cosine theta, using that right angle triangle ROT, cosine theta is equal to R divided by OT. So R, which is substituted for OT, so little r is equal to big R, which is the OT value, times cosine theta. So little r, or the radius of a line of a circle of latitude, will always be expressed as the radius of the Earth times cosine of the angle of latitude. Here is an example. Calculate the radius of the circle of latitude at 40 degrees north. So we draw a sketch of the Earth. We establish the North Pole and the South Pole. We draw in the line to represent the equator. We establish the longitude line for Greenwich meridian, And we establish this circle north of the equator, 40 degrees north, which is a circle shown there. And we are given point A, which is 34 degrees east, that is going to your right, is going to the east. And then we locate the point B, 65 degrees east. So point B is further east than point A. Let's look at this solution. Let R represent the radius of that latitude circle. We know that little r is equal to big R cosine the angle, which is theta. We are told that the radius of the Earth is approximately 6,370 kilometers. So little r is equal to 6,370 times cosine 40. That's cosine 40 degrees. Put this value into your calculator, and so you can find cosine 40 and multiply that answer by 6,370, and we have the radius of the circle of latitude 40 degrees north as 4,880 kilometers. Here is your problem for today, taken from CXC June 2004. The tongues A and B are both on the circle of latitude 24 degrees north. The longitude of A is 108 degrees east, and the longitude of B is 75 degrees east. Assume that the radius of the Earth, R, is equal to 6,370, and use 3.14 as the value for pi. 1. Copy the sketch of the Earth and insert the points A and B on the diagram. A very simple exercise. Part 2. Calculate correct to the nearest kilometer the radius of the circle of latitude 24 degrees north. This is a problem given to you in the last lesson, CXC January 2007. Pam visits the stationery store where she intends to buy X pens and Y pencils. Part A. Pam must buy at least 3 pens. Write an inequality to represent this information. The total number of pens and pencils must not be more than 10. Part 2. Write an inequality to represent this information. Each pen costs $5 and each pencil costs $2. More information about the pens and pencils is represented by 5x plus 2y is greater than or equal to 35. Part 3. Write the information represented by this inequality as a sentence in your own words. Part B, Section 1. Draw the graph of the two inequalities obtained in A Part 1 and A Part 2 above. Part 2. Write the coordinates of the vertices of the region that satisfies the 4 inequalities, including y greater than or equal to 0. part C of the question. PAM sells the X pens and Y pencils and makes a profit of $1.50 on each pen and $1 on each pencil. Part 1. Write an expression in X and Y to represent the profit PAM makes. Part 2. Calculate the maximum profit PAM makes. Part 3. If PAM buys 4 pens, show on your graph the maximum number of pencils she can buy. Here is the solution. Part A. First, we must establish the line x equal to 3. And if you look on the diagram, it is a second vertical line. So that is one reference line that we need to establish. So for x to be greater than or equal to 3, it will include all points along the line x equal to 3 and all points to the right of that line. The next part, we have to establish the line x plus y is equal to 10. Notice the sloping line going down from the point 10 on the y-axis to the point 10 on the x-axis. That line, if the points are plotted, will be the line x plus y is equal to 10. But we have to identify the region for x plus y less than or equal to 10. So that region would be all points on the line and below the line. So we are recognizing that that is a portion of the shaded part. The third part, we are asked to express that inequality in words, and these are my words. The total cost of pens and pencils must not be less than $35. Then part B of the question asks you to draw the graph, which is seen on the slide here. We are asked to identify the points that will satisfy the 4 inequalities. That is the point 37, it's marked there, 37, and you see next to it 3 pens, 7 pencils. The next point will be 10, 0, which is where that sloping line crosses the x-axis or the pen axis. Then we have 3, 0. If you look at the graph, the point on the x-axis again, where the second vertical line crosses the x-axis, that is a point 3, 0. So those are the 3 points given around the solution region. The next part would be the equation or an expression for the profit. The expression for the profit is 1.5x, that is $1.50 times x, which is expressed as 1.5, plus 1 times 1, which is just y. And the profit that is made when the calculation is done, when the values are substituted in the profit expression, that is 1.5x plus y, when we substitute the profit value, we'll end up with PAM making a profit of $11.50. This brings us to the end of today's program, CXC Mathematics in Focus.
In this lesson, we will be looking at descriptive writing. In Section 3 of English A, Paper 2, you're sometimes given the option between writing a story or description. Here are some guidelines for writing descriptive essays. You must know exactly what you want to describe: a person, a place, a memory, an experience, or a scene. You must decide on what aspect you want your description to focus. In writing your description, you must show, not tell. Consider the following sentence: I grew tired after dinner. Now, how can you write to show such tiredness? Let's see how this next sentence does it. As I leaned back and rested my head against the top of the chair, my eyelids began to feel heavy, and the edges of the empty plate in front of me blurred with the white tablecloth. The most effective descriptive essays are loaded with such showing because they enable readers to imagine or experience something for themselves. As you write your descriptive essay, the best way to create a vivid experience is to focus on the 5 senses: sight, sound, touch, taste, and smell. Let's look at another example of writing descriptively. It was hot. It was too hot. The girl stood beside the road and waited. She was so uncomfortable that she lifted her hair off her neck to cool down. She began to sweat. Let's see how the above sentence can be written descriptively. Humidity breathed in the girl's face and ran its greasy fingers through her hair. As she stood looking down the long deserted road, she could see heat vaporizing in the distance, creating a rippled, watery effect. She frowned and lifted her hair off her neck. A drop of perspiration slid down her spine. What are some of the characteristics of good descriptive writing? Good descriptive writing includes much vivid sensory details that paint a picture and appeal to the reader's senses. Good descriptive writing makes good use of figurative language, such as similes, metaphors, personification, and onomatopoeia. Good descriptive writing uses precise language, specific adjectives, and adjectival phrases, along with strong action verbs to give life to the word picture you are creating. Good descriptive writing is organized. Some ways to organize descriptive writing include chronological, sequence, spatial arrangement, and order of importance. Good descriptive writing creates lively atmosphere. The atmosphere is the dominant effect created by the surrounding events or elements of your description. Each paragraph of your descriptive essay should focus on one aspect of the description. Your paragraphs should be ordered in the most effective way. Let us now turn our attention to some longer descriptive pieces. In the descriptive extract below, Mark Twain paints a vivid picture of a storm. He describes the storm as if it were a battle. Let's see how he does this. "Quick, boys, go for the tent," exclaimed Tom. They sprang away, stumbling over roots and among vines in the dark, the two plunging in the same direction. A furious blast roared through the trees, making everything sing as it went. One blinding flash after another came, and peal on peal of deafening thunder. And now a drenching rain poured down, and the rising hurricane drove in its sheets along the ground. The boys cried out to each other, but the roaring wind and the booming thunder blasts drowned their voices utterly. However, one by one they struggled in at last, and took shelter under the tent, cold, scared, and streaming with water. But to have company in misery seemed something to be grateful for. They could not talk. The old sail flapped so furiously, even if the other noises would have allowed them. The tempest rose higher and higher, and presently the sail tore loose from its fastenings and went winging away on the blast. The boys seized each other's hands and fled, with many tumblings and bruises, to the shelter of a great oak that stood upon the river bank. Now the battle was at its highest. Under the ceaseless conflagration of lightnings and flames in the skies, everything below stood out in clean-cut and shadowless distinctness. The bending trees, the billowy river, white with foam, the driving spray of spume flakes, the dim outlines of high bluffs on the other side, glimpsed through the drifting cloud rack and the slanting veil of rain. Every little while some giant tree yielded the fight and fell crashing through the younger growth, and the unflagging thunder peals came now in their splitting explosive bursts, keen and sharp, and unspeakably appalling. The storm culminated in one of matchless effort that seemed likely to tear the island to pieces, burn it up, drown it to the treetops, blow it away and deafen every creature in it. All at one and the same moment. It was a wild night for homeless young heads to be out in. But at last the battle was done, and the forces retired with weaker and weaker threatenings and grumblings, and peace resumed her sway. The boys went back to camp a good deal awed, but they found there was still something to be thankful for, because the great sycamore, the shelter of their beds, was a ruin now, blasted by the lightnings, and they were not under it when the catastrophe happened. Everything in camp was drenched, the campfire as well, for they were but heedless lads like their generation, and had made no provision against rain. Here was matter for dismay, for they were soaked through and chilled. They were eloquent in their distress, but they presently discovered that the fire had eaten so far up under the great log it had been built against, where it curved upward and separated itself from the ground, that a handbreadth or so of it had escaped wetting. So they patiently wrought until, with shreds and bark gathered from the undersides of shelter logs, they coaxed the fire to burn again. Then they piled on great dead boughs till they had a roaring furnace, and were glad-hearted once more. They dried their boiled ham and had a feast, and after that they sat by the fire and expanded and glorified their midnight adventure until morning, for there was not a dry spot to sleep on anywhere around. And this is taken from the Adventures of Mark Twain, from the Adventures of Tom Sawyer by Mark Twain. Let us look at another description written by Karen, an 11th grader, who shares the details of a Saturday spent working for the family business. Let's see how she makes use of sensory details. I look at the old tin building. It seems to have been there since the beginning of time. Its strong posts and nonchalant slouch make me wonder if it will be rooted in the same place forever. As soon as I walk in, the strong rustic smell of hickory wood assails me. It takes me back to my family's last 4th of July barbecue, when the hickory chips smoking the ribs give off their thick aroma, I wait for my eyes to adjust in the dark, humid place, not taking a step until they do, because of the ageless spider that could have made its home in my path. My tongue already asks for a drink of water as I breathe the musty air littered with sawdust. Spraying on sticky repellent, I wonder if the thirsty mosquitoes will stay away. I walk to my work area, making sure I do not trip over the precious finds and the hopeful antiques. I brush against the wall of the old building that is really more of a shed, and a mat of spiderwebs cling to my shirt and refuses to come off. The gentle hum of the small fans and the roar of the monster fight against the humid air. I put out a machine that is supposed to tie the 2-pound bags that are full of hickory chips, but it has a mind of its own. Placing the bulky machine on the high bench with its layers of gritty sawdust, I hope it has decided to work today and load a bag into it. As I pull down the top of the machine, I stare in its mechanical eyes, willing it to work. I pull the bag back out of the machine and look down on another battle lost. For now the brute has won the war of wills, and I prepare myself with a box of red ties to close all 1,000 of the smooth bags by hand. The clang of the shovel dumping its first load onto the ancient scale can be heard throughout the shed, signaling that work has begun. The salty sweat begins to bead on my forehead, and for the first time of many times, I wipe it away, leaving a smudge of dirt and dust. Already I yell, "First shower," to assure my place in the line after our work is completed. I hear my 3 sisters shout numbers throughout the shed. Amanda, the last to call a number, frowns, knowing she'll have to wait a long time for the hot water to return after all the showers. My grandfather walks into the shed, a cane in one hand and a pack of icy cold colas in the other. His deep southern drawl permeates the building as he asks if we've had lunch yet. Our eyes brighten and smiles play on our faces as we silently hope he will offer the traditional sloppy whopper and golden fries. He leaves as silently as he came in, and our stomachs start to growl with anticipation for lunch. My sisters and aunts, chatting and soft laughter, started as they begin to catch up on each other's lives. I look around wondering what people would say if they could see the home sisters outside of the house with no makeup on and their hair in disarray. I laugh and keep the thoughts to myself, listening in as my aunt's next story begins. At the end of the day, when all of the work is done, I pull the pallet or makeshift gate closed and pet my grandfather's latest endeavor at a vicious watchdog. I sigh with relief that it's over, even though sometimes I dread the thought of work, especially when I know it is going to occupy another Saturday. The time spent with my family and the laughter shared will always be worth the sweat and scrapes. The memories will always be treasures in my mind and will continue to be among the things laugh about and love the most. Let us now examine a third description taken from The Pearl by John Steinbeck. As you read this extract, note carefully the writer's use of details to create atmosphere. There is a strong atmosphere of tension, panic, and desperation. There is also a sense of harshness. Everything around seems to be offering resistance against the protagonist. Let's see how the writer achieves this. Frantically, he gathered the gourds and the little bags that were their property. Kino carried bundle in his left hand, but the big knife swung free in his right hand. He parted the bush for Wana, and they hurried to the west, towards the high stone mountains. They trotted quickly through the tangle of the undergrowth. This was panic fight. Kino did not try to conceal his passage. he trotted, kicking the stones, knocking the telltale leaves from the little trees. The high sun streamed down on the dry, creaking earth, so that even the vegetation ticked in protest. But ahead were the naked granite mountains, rising out of erosion rubble and standing monolithic against the sky. And Kino ran for the high place, as nearly all animals do when they are pursued. This land was waterless, furred with the cacti which could store water, and with the great rooted brush which could reach deep into the earth for a little moisture and get along on very little. And underfoot was not soil but broke rock, split into small cubes, great slabs, but none of it water-rounded. Little tufts of sand-dry grass grew between the stone grass that had sprouted with one single rain and headed, drooped its seeds, and died. Horned toads watched the family go by and turned their little pivoting dragon heads. And now and then a great jackrabbit, disturbed in his sleep, bumped away and hid behind the nearest rock. The singing heat lay over this desert country, and ahead the stone mountains looked cool and welcoming. So, boys and girls, there you have 3 sets of descriptive pieces. Again, if you are going to choose the description instead of the story, you have to practice regularly. Until the next time, I'm Ingrid Fong saying good night on behalf of Bibi Ali, Parmeshwarlal, and Ron Chichester.
The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. Lesson 40, Earth Geometry, Location of places on the Earth's surface. In this lesson, we will calculate 1. The distance between 2 points on the Earth's surface, and 2. Determine the latitude and longitude of a point on the Earth's surface given its distance from another point on the same parallel of latitude or on the same meridian. Here are some key points to note. 1. All great circles, the equator or the meridian, have the same radius, r. It's big R. Part 2. All the lines of latitude except the equator are small circles and have different radii labeled little r. Notice the diagram on the right. You have the North Pole, the South Pole, the Greenwich Meridian, the equator, and at the top you see circle of latitude, and there are many such circles on the globe. Some other points to note. 1. Geographic grids are intersecting lines drawn on maps and globes. They are used to help locate specific areas or specific position Part 2. The shortest distance between any two places on the Earth's surface refers to the minor arc of the circle passing through them. Again, if you look at the diagram on the right, the same diagram, just keeping you focused on where the equator is, what are lines of latitude, and the lines of meridian, including the meridian of Greenwich. Let us look at a problem taken from CXC June 2006. 2 points Y and M on the surface of the Earth have coordinates Y 41 degrees north, 74 degrees west, and M 41 degrees north, 4 degrees east. 1. Calculate the circumference of the circle at latitude 41 degrees north. Part 2. Calculate the shortest distance between Y and M measured along the circle of latitude 41 degrees north. Look at the diagram. We establish the North Pole, the South Pole. We establish the 41 degrees north latitude circle above the equator, and we locate the meridian of Greenwich, which is seen there, and that is used to identify the points on the circle. Point M is 4 degrees east of meridian of Greenwich. Point Y is 74 degrees west of the meridian of Greenwich. We'll see how to solve the problem in a moment. The solution. First part. We need to know the radius before finding the circumference of the circle at latitude 41 degrees north. For that circle, we need to establish the radius. So we say let little r represent the radius of the circle at 41 degrees north. So we'll have the formula which we derived earlier as little r is equal to big R cos the angle of latitude, which is equal to 6,370 cos 41 degrees. And when we put these values in the calculator, we'll discover that little r is 4,807.5 kilometers. That is the radius of the circle at latitude 41 degrees north is 4,807.5 kilometers. Let's see represent the circumference of that same circle at 41 degrees north. Circumference is equal to 2 pi r, and when the values are substituted, we'll have 2 times pi, pi being 3.14, times 4,807.5, which is a value we have calculated a moment ago. And when these values are put into the calculator, we obtain a result of 30,191 kilometers. The solution continues. Part 2. We will use C, that is the circumference, of 30,191 km from the first part to find the shortest distance between Y and M measured along the circle of latitude 41 degrees north. 360, that's right around the circle, will correspond to the circumference, which is given as 2 pi r. So 78 degrees, we do our proportion calculation here. So it is 30,191 divided by 360 to find for 1 degree, then multiply by 78 to find for 78 degrees. When these values are placed in your calculator, the answer obtained would be 6,541 kilometers. And you can continue to look at the diagram to see the various positions and to identify y and m. If we cut that circle, we will find that little circle at the bottom there indicating a section of the globe. Here is another example. Two airports, S and T, are located at 30 degrees north, 25 degrees west, and 30 degrees north and 20 degrees east, respectively. Calculate the shortest distance between S and T along the parallel of latitude. Question taken from CXC June 2006. To find the radius of the circle at 30 degrees north latitude, again we use our standard formula. Little r is equal to big R cos theta, big R being the radius of the earth, which will give us 6,370 cos 30, which is equal to 5,516.6 kilometers. But angle SOT, notice that, SOT is equal to 25 plus 20, which will give us 45 degrees. So that distance, that angular distance, 45 degrees, is equal to 45 over 360 times the circumference to find the distance ST. So it is 45 over 360 times the circumference, which is 2 times 3.14 times 5,516.6, which will give us 4,330.5 kilometers. So the distance between S and T is 4,330.5 kilometers. This example is taken from CXC January 2000. A plane flies due east from tongue H, 65 degrees north, 34 degrees west, to tongue Q, 65 degrees north, x degrees east. The distance along the parallel latitude between H and Q is 4,011 kilometers. Calculate the value of x, that is, the size of the angle x. The picture on the right will illustrate the movement, the point H, the point M, and the point Q. To find the radius of the circle at 65 degrees north, little r is equal to big R cos theta, which is equal to 6,370 cos 65, which will give us 2,692 kilometers. 4,011 is equal to 360 divided by 2 times 3.14 times 2,692 times 4,011. When that is worked out, and that's a ratio exercise, when that is worked out, we'll have 85 degrees. That is, 4,011 km will correspond to an angular measure of 85 degrees. But angle SOT is equal to 34 plus x degrees, And look at the diagram and you will see why. So the longitude of Q is equal to x, which is equal to 85 minus 34, which will give us 51 degrees east. Here is a problem for today taken from CXC June 2005. The latitudes and longitudes of Antigua and of Belize are given in the table below. Antigua 17 degrees north, 62 degrees west. Belize 17 degrees north, 88 degrees west. Part 1. Calculate the shortest distance between Antigua and Belize measured along their common circle of latitude. Part 2. A town, Bahia Blanca, situated in South America, lies on the shortest distance between Antigua and Bahia Blanca, measured along the common circle of longitude. Here is the problem given to you in the last lesson. The tongue A and B are both on the circle of latitude 24 degrees north. The longitude of A is 108 degrees east and the longitude of B is 75 degrees east. R, the radius of the earth, is 6,370 kilometers and the value of pi is equal to 3.14. Copy the sketch of the earth and insert the points A and B on the diagram. The diagram is on the right. Part 2. Calculate correct to the nearest kilometer the radius of the circle of latitude at 24 degrees north. Here is the solution. We are asked to calculate the radius of the circle of latitude at 24 degrees north. Let r represent the radius. We know that r, small r, is equal to big R cos theta. Substituting the values, we'll have small r is equal to 6,370 cos 24 degrees, which will give us 5,819.28 kilometers. And if you look at the diagram, it will help you to see the position of what is small r and what is big R. Remember that big R is the radius of the earth, 6,370 kilometers. This brings us to the end of today's program, CXC Mathematics in Focus.
In this lesson, we will look at another aspect of persuasive writing, advertisements. The advertiser uses different ways to persuade the consumer to purchase the product or service that is being advertised. As humans, we all have certain needs, desires, and feelings. Advertisers target these basic human needs, desires, and feelings when they promote their products and services for sale. Some of the human desires and needs that advertisers target are to feel important or to identify with an important class of people, to feel attractive to others, especially those of the opposite sex, to feel safe and secure, to find an easy path to success, to be recognized and admired by others, to have problems solved quickly, to have work made easier, to feel strong and powerful, physically or otherwise, to feel accepted and liked by others, to enjoy a life of pleasure, to get ahead of other people. The advertiser appeals to these desires in people by using various techniques of persuasion. These techniques include the use of emotive language, words and expressions that make a strong appeal to people's emotions, the use of repetition, alliteration, and assonance, the use of pun, a play upon a word for a stylistic effect, the use of scientific evidence to give authority and validity to the claims made by the advertisement, the use of statistical information about the widespread use of the product so that consumers can feel safe in using it, the use of exaggeration to show how good or effective the product or service is, or how it is better than similar products or services, the use of rhetorical questions to appeal to consumers' emotions, as well as to reinforce claims made, the use of catchy phrases and popular sayings for sensational appeals, the use of bold lettering and pictorial illustrations to appeal to the visual sense. Let us now consider the following advertisement and try to identify the writer's appeals to human needs and desires, as well as the techniques the writer uses to make the appeals. Now, what have you noticed? What appeals does the advertisement make? The advertisement appeals to young people to belong to a certain social group. The word gang is a group identity word. The advertisement appeals to older people as well as those who have a desire to feel young and to identify with the younger generation. There's an appeal to people's needs for pleasure, strength, and recognition. Swing keeps you happy, vibrant, and popular, and you won't be left behind. There is also an appeal to people's desire for success. What are the techniques used by the advertiser? Visual appeal. The word swing is emboldened and written artistically at the start to create the effect of something swinging. Repetition. The expression drink swing is repeated. Use of exclamation. This appeals to consumers' sense of urgency to drink this beverage. The use of pun. The word swing at the beginning is the name of a drink, and it also calls upon consumers to take an action. Now, let us look at a comprehension exercise that is based on an advertisement. This question appeared in English A Paper 2 some years ago. Read the following extract carefully and then answer all the questions on it. What do you get when you put a superb 5-star hotel on a great Caribbean beach? Nothing much. Only the power of occasion, that's all. What is the power of occasion? Nothing much. Just a 10-day, no compromise holiday. Nothing much. Just flat out sea and sun, luxury accommodation, and great dining. No expense has been spared to make the Orion Hotel, around which the entire power vacation revolves, the only option for those who cannot stand a compromise. Within the privacy of its 22 dramatically landscaped acres lies luxury beyond expectation. The luxury we offer is often based on choice, choice between 5 different restaurants with the most exquisite menus, choice of several fascinating water spots, and the option of doing nothing but lying on the beach or watching the sunset from your private balcony or from the Orion's own luxury yacht. Your suite, there are no rooms at the Orion, has a stunning view of the bay, and money is redundant since you've already paid for everything before you arrive. We don't even allow tipping. Only a very special breed of individual is able to enjoy the power vacation. Are you one of this breed? Now let us answer these questions. What is the main